My name is Desmond Edagese, and I'm here to take us on the subject mathematics. Today we'll be looking at the theme basic operations. And under basic operations, we'll be looking at basic operations in fractions. This class is a continuation of the last series that we did in the topic of fractions. In that class, we learned what a fraction is, we learned about equivalent fractions, and we also learned how to order fractions. Well, in this class, we'll be learning how to carry out basic operations in fractions. In the course of our class today, here are some of the things that we expect to learn. First, we'll learn about the conversion of fractions to decimals and percentages. Next, we'll learn how to add and subtract fractions. And finally, we'll learn how to multiply and divide fractions. Now, fractions can exist in different forms. Percentage is a form of fraction. It's a type of fraction that has its denominator always as the number 100. The word percentage, in fact, means the part of 100. The symbol for percentage is this symbol here. This symbol is called a percentage. So, if I write 30 and I write the symbol after 30, it means 30%. That's the way we call it, 30%, which of course tells us that 30 is divided by 100. So again, a percentage is a type of fraction, all right? 30 over 100 is a percentage, and we write it as 30% by making use of our symbol. Now, to convert percentages to fractions, there are certain rules that we must follow. First, we write down the percent and we divide it by 100. So if we have 75%, it means that we divide 75 by 100. Next, we simplify or we reduce our fraction to its lowest possible term. We simply divide 75 by 100. First, let's divide by 5. If we divided 75 by 5, we would have 15. 100 by 5, if we divided 100 by 5, we would have 20. If we further divided 15 by 5, we would have 3. And if we further divided 20 by 5, we would have 4. Of course, there is no number that can divide both terms equally anymore. It simply means that 3 over 4 is the lowest term possible that we can have. 3 over 4 is our fraction. And that's how we can do conversions from percentages to fractions. Let's take some examples for better understanding. If you were asked to express 35% as a fraction in its lowest terms, again, we follow our steps to write down our percentage divided by 100. 35% simply means 35 over 100. We'll simply simplify 35 over 100 to get the lowest possible term. And of course, if we found numbers that would multiply that are common between 35 and 100, would have 7 times 5 is same as 35, 20 times 5 is same as 100. Of course, 5 will divide 5, and that would leave us with what? 7 over 20. This is simply another way to find the lowest term. Another way of simplifying. You can simply divide through or get factors that are common between the numerator and denominator. In this case, it was 5 that is common, and we divide 5 out to give us 1. 7 over 20 becomes our answer. So 35% can also be written as 7 over 20. Next, if you are also asked to express 64% as a fraction in its lowest term, again, we write 64% as 64 all over 100. We also go ahead to simplify this. Let's find two factors, that is two numbers that will multiply that will give us 64, and also find two numbers that will multiply that will give us 100, bearing in mind that each number that we find, or each numbers that we find, there should be a common number that we can divide to give 1. 16 times 4 will give us 64. 25 times 4 will give us 100. 4 divided by 4 will give us 1, and we will be left with what? 16 over 25. This is the lowest term possible. It simply means that we cannot further divide it or we cannot further simplify. So 16 over 25 is our answer. 64% can be rewritten as a fraction to give us 16 over 25. We just learned how to convert percentages to fractions. Now we will learn how to convert fractions back to percentages. We follow 3 simple steps to do that. First, find a number that we can multiply the denominator with that will give us 100. All right? If, for instance, 9 over 25 was given to us as the fraction, and we were asked to convert it to a percentage, find a number that you can multiply with the denominator to give you 100. 25 is our denominator here. What can we multiply with 25 to give us 100? 4. So we multiply 25 times 4 to give us 100. 4 is the number we're interested in. We will multiply next the numerator and our denominator by the number 4. That is, whatever we do to the numerator, we also do it to the denominator, so we can have our equivalent fraction. Remember, we learned about equivalent fractions. But in this case, our denominator that we seek will be 100. So let's do that. 9 over 25 multiplied by 4 all over 4. 9 times 4 would give us 36. While 25 times 4, of course, would give us 100. This is an equivalent fraction to our original fraction, 9 over 25. The last step in converting our fraction to percentages is simply to express our percent, that is, the numerator, 36, as a percentage by adding the symbol of the percent. So 36 over 100 is the same thing as what? 36%. We simply add our symbol and we have our percentage. Let's take some examples to better understand. If you were asked to express 3 over 4 as a percentage, what do? First again, we find a number that when we multiply it with our denominator, which is 4 here, it would give us 100. 4 times 25 will give us 100. It means that 25 is a number we are very much interested in. Next, we multiply both the top of our fraction and the bottom, that is the numerator and denominator, by the same number. 3 over 4 times 25 all over 25. We simply multiply 3 times 25. That would give us 75. 4 times 25, of course, will give us 100. And to finish our work, we have 75 over 100, which can be easily expressed in percentage form as 75. And then we add our symbol of the percent. This is 75%. So we've been able to convert 3 over 4 and write it in the percentage form to give us 75%. Let's also look at this example. Express 4 over 5 as a percentage. Again, following our 3-step rule, first, find a number that when you multiply 5 with that number, it will give you 100. 5 times 20 will give you 100. 20 is the number we are interested in. We multiply both the top and the bottom of our fraction by 20. All right? 4 over 5 times 20 all over 20. 4 times 20 would give us what? 80. 5 times 20 would give us 100. 80 over 100 can be rewritten as a percentage. We simply write our percent and add our symbol of percentage. 80% is another form of the fraction 4 over 5. Now, we said earlier that there are different forms in which fractions can be written. We've learned about the percentage, which is a form of fraction. Also, we have the decimal. The decimal is another form of fraction, as we're going to be learning about shortly. We're going to be looking at what a decimal is and how we can convert a fraction to a decimal and a decimal back to a fraction. All right? A decimal is a special type of fraction whose denominator is a power of 10. That is, it could be 10, it could be 100, it could be 1,000, it could be 1 million, different powers of 10. Our denominator is a power of 10. It is usually written as a whole number followed by a dot. We call it a decimal point, all right? Written before the numerator. 4 over 10, for instance, is a fraction. If we were to rewrite it in the decimal form, okay, we would write, like we said, 0 point, that's the decimal point, and 4, which is our numerator. So 4 over 10 is same as 0.4. This is the decimal form of 4 over 10. How did we convert 4 over 10 to give us 0.4? Let's go to our next slide, and then we'll learn how we came about that. Now, to convert fractions to decimals, we can use either of two methods. In the first method, we can divide our numerator by the denominator directly while writing down our decimal point as it arises. Let's look at what we mean. 2 over 5 is a fraction. If we were asked to find the decimal form of the fraction 2 over 5, how do we go about that? 2 over 5 as a fraction simply means 2 divided by 5. All right? How do we get 2 divided by 5? Let's write our number here, 2. 5 is expected to go into 2 and, of course, give us a value. Of course, 2 is less than 5. So 5 on its own cannot go into our number 2. Hence, we put down 0. Okay? It means that 5 cannot go into 2 as a number. We put down 0. Next, we put down our decimal point. That's the dot. And we merge our 2 with the next number, which is 2.0 here. We merge 2 and 0 to give us 20. Now we say 20 divided by 5. Of course, 5 can go into 20 to give us how many whole number? 4 whole number. So 5 in 20 gives us 4. Hence, our final answer, when we find 2 divided by 5 is what? 0.4. 2 divided by 5 is 0.4. That's one direct way of finding our decimals from fractions. Let's take a look at the other way. The second method lists out 3 different rules. The first rule says that we multiply our fraction. Let's say 4 over 5 was given to us as a fraction. We multiply 4 over 5 by a denominator, which is a power of 10. Let's multiply our fraction by 10. 10 over 10, of course, will give us 1. All right? If we multiplied 4 times 10, we'll have 40. 5 times 10 will give us 50. 40 over 50 is an equivalent fraction to 4 over 5. The next step, we divide both the top and the bottom of our new fraction. 40 over 50 is our new fraction. Divide it by the initial denominator. 5 is our initial denominator. So divide top and bottom by 5. 40 divided by 5 would give us 8. 50 divided by 5 would give us 10. So we also have 8 over 10 as our answer. But to write it in the decimal points, we follow our third rule. To do that, write down the top number. Okay? Our top number here is 8. That is our numerator. Then write the decimal point in its spot. This point is very important as we learn how to convert fractions to decimals. To know where to put our decimal points, we count the space from the right-hand side, considering the number of zeros in our denominator. We have 1 0. So we move our decimal points 1 step, and of course we add 0 to the other side. Our answer becomes 0.8. It means that if our denominator here was 100, we have 2 zeros, we would have moved our decimal point 2 steps, and that would have given us 0.08. But in this case, our answer is 0.8 because we have just 1 0 in our denominator. So this rule, that is the third rule here, is very important when we have a numerator divided by a power of 10. These are the 2 methods that we have in converting fractions to decimals. Let's take some typical examples for better understanding. If we were asked to express 3 over 4 as a decimal, let's make use of our second method, all right? To make use of our second method, what did we say? We multiply the top and the bottom of our fraction by a power of 10. When we say power of 10, it could be 10, it could be 100, it could be 1,000, and so on. In this case, we would make use of 100. 100 is a power of 10. So 3 over 10 times 100 over 100. 3 times 100 will give us 300. 4 times 100 will give us 400. 300 over 400 is an equivalent fraction to 3 over 4. In the next step, we divide our numerator and denominator by the previous denominator, that is, the denominator that we had in the original fraction, which is 4. So 300 divided by 4 would give us 75. 400 divided by 4 would give us 100. We have our fraction now with our denominator as a power of 10. We can now easily express this as a decimal. To do that, remember we said the most important step so far, write down the numerator, which is 75. Count the number of zeros in the denominator, 1, 2. It means that our decimal point will move 1 step, 2 steps to come in front of our numerator, and then we add 0 to the left side. Hence, we have 0.75 as the decimal form of our original fraction 3 all over 4. That's how simple it is. Let's use the first method that we learned about to express 5 over 8 as a decimal. Okay? 5 over 8, which is a fraction, simply means 5 divided by 8. Let's see if we can divide 5 by 8. Notice that 5 is smaller than 8. All right? 5 and 5.000 and so on, they are the same thing. That is, 5 is the same as 5.000 or 5.0, whatever the case may be. Take note. All right? So when I write 5.00, I'm still referring to our whole number 5. 8 goes into 5 is not possible. It's impossible for 5 to be divided by 8. Hence, we do what? We write down 0. 0 tells us that, of course, 8 could not go into 5 because 5 was smaller than 8. Then we put our decimal point next. We merge 5 and the next 0 to give us a whole number 50. Now 8 can go into 50 to give us 6. 8 times 6 would give us 48. It means that 8 would go into 50 to give us 6, which gives us the number 48. Of course, remainder 2. We have a remainder of 2. Let's put that 2 somewhere to remind us. Next, we merge the next 0 with 2 to have 20 as a number. 8 can also go into 20. How many times? 2 times. All right? 8 times 2 would give us 16. It means that we have 4 as a remainder. Again, let's put down that 4 as a remainder somewhere. Also, we merge the next 0 to 4 to give us a number 40. Now, 8 can go into 40. How many times? 5 times exactly. So, there ends our division. Since we have a whole number, we no longer have remainders where we need to continuously merge the 0 and divide by 8. It means that 5 divided by 8 has given us the decimal 0.625. 0.625 is the decimal form of the fraction 5 over 8. Now we've learned how to convert fractions to decimals. Let's see how we can convert decimals back to fractions. To do that, we follow 3 simple rules. First, write down the decimal all over the number 1. If 0.75 is the decimal that you were given, simply write it all over 1. Next, multiply the top and the bottom of our fraction by 10 for every number after the decimal point. What we mean is 7 and 5 are two numbers after the decimal point here. It means that we will multiply 0.75 over 1 times 100 all over 100. We chose 100 because we had two numbers after our decimal point. If we had just a number, say for instance 0.7 over 1, we'll multiply the top and bottom by 10. Okay, 1, 0, one number after the decimal point. I hope it's clear. Let's go on. 0.75 all over 1 will multiply the top and the bottom by 100. That is, 0.75 times 100 will give us 75. 1 times 100, of course, would give us 100. Now we have a fraction 75 all over 100. We simply go ahead to simplify our fraction. All right? We divide 75 over 100 by common terms, and that would give us 3 over 4 as the simplest possible fraction. Let's take a look at some examples. If you are asked to express 0.98 as a fraction in its lowest term, first, we write our decimal all over 1. 0.98 is written as 0.98 all over 1. Next, we multiply the top and the bottom of our fraction by 100 because we have two numbers after the decimal point. Let's look at our number again, 0.98. 9 is one number after the decimal point, while 8 is another number. We have two numbers after the decimal point. And that's why we use 100 to multiply the top and the bottom. So let's do that quickly. 0.98 times 100 all over 1 times 100. 0.98 times 100 will give us 98, while 1 times 100 will give us 100. We simply go ahead to simplify our fraction to the lowest possible term. If we did that, say for instance, divide 98 by 2, that would give us 49. 100 divided by 2 will give us 50. This is the lowest possible term because we cannot further simplify 49 over 50. Let's take a look quickly at another example. Express 0.32 as a fraction in its lowest term. Again, we follow our steps. Write 0.32 all over 1. Okay? Multiply the top and the bottom by 100 for the two numbers that are after our decimal points. Here's our decimal point. 3 is one number after the decimal point. 2 is another number after the decimal point. Hence, we use 100 to multiply the top and the bottom of our fraction. 0.32 times 100 will give us 32. 1 times 100 will give us 100. 32 over 100 is a fraction, but it can be further simplified. If we simplify that further, we'll have a fraction 8 over 25, which cannot be further simplified. Hence, this is the lowest possible term of the fraction. So 8 over 25 is another way or another form of writing 0.32, which is a decimal. Now, there are rules that govern the addition and the subtraction of fractions. Let's take a look at some of these rules. Before we go into our rules, there are things we need to take note of. We can only add or subtract fractions that have the same denominator. In our previous class, we learned about equivalent fractions. All right? So, only equivalent fractions can be directly added together. Now, let's look at our 3 simple rules to adding or subtracting fractions. First, make sure the denominators are the same. That is, make sure the fractions are equivalent. If they are not, we learned in our previous class how to make them equivalent fractions. In order to do that, we'll find the lowest common denominator and thereby make these fractions equivalent. If we've been able to do that, next we simply add or we subtract the numerators and we put our answer over the common denominator. If the fractions that we have, in this case, is not simplified, you can go ahead to simplify them if needed. Take note that if you have mixed fractions, first change them to improper fractions for easier addition or subtraction. Let's take a look at some quick examples. If you were asked to find 1 over 4 plus 1 over 4, quickly take a look at the denominators. They are the same. For such cases, they are very simple to add. We simply add up the numerators, 1 plus 1, which would give us 2, and we put it all over the common denominator, which is 4. 2 over 4 can be simplified to give us 1 over 2. This is exactly what it looks like in real life. If you were given a quarter, remember we said 1 over 4 is a quarter pizza, while someone else also gave you a quarter pizza, if you added them together, you would have 2 over 4 pizza, of course, which is further simplified. It simply means you have half pizza. So a quarter and a quarter would give you a half. Next, let's look at this other example. 13 over 15 minus 2 over 15. Quickly again, take a look at the denominator. 15 and 15 are common to both fractions. So we can simply quickly do the subtraction here by saying 13 minus 2, which is 11, all over the common denominator 15. 11 over 15 is our answer because it cannot be further simplified. Let's take a look at some examples that have different denominators. Remember we said when we have different denominators, we cannot exactly add up those fractions normally. We need to carry out an operation on each fraction to ensure that they have a common denominator. How do we do that? We learned in our previous class how to find the LCD, that is the lowest common denominator. To do that, we take the first denominator here, which is 12, and we find the multiples of 12. We have 12, 24, 36. Multiples of 8 also we will find to be 8, 16, and 24. 24 is common between both multiples. All right? So let's say our LCD or the LCM, which we use interchangeably, is 24. Now we convert our fractions 7 over 12 and 3 over 8 by giving them this common denominator. How do we do that? We find a number that if we multiply 12 by, which is our first denominator, it would give us 24. That number is 2. We multiply the top and the bottom of our fraction by the number 2. 7 over 12 times 2 over 2 would give us, 7 times 2 is 14, 12 times 2 is 24. This is an equivalent fraction to 7 over 12. We'll do the same thing for 3 over 8, and we have 9 over 24. So we have two equivalent fractions that both have a common denominator. Now we can easily carry out our addition. 14 over 24 plus 9 over 24 would give us 14 plus 9, which is 23, all over our common denominator here, which is 24. 23 over 24 is the lowest possible term that we can get for our fractions. Hence, that's our answer. Also, we learned while we were explaining how to go about carrying out addition and subtraction and fractions that when we have a mixed fraction like this, we first convert it to an improper fraction. All right? Also, take note that the denominators are also different. But first, let's quickly carry out our conversion from mixed fractions to improper fractions for both of our fractions. 6 whole number 5 over 12 minus 3 whole number 3 over 4 would become, in converting our mixed fractions, how do we go about that? We multiply our denominator by the whole number. 6 times 12 is 72, plus 5 is 77. So we have 77 over 12. We do the same thing for other mixed fraction. 3 times 4 is 12. 12 plus 3 is 15. We have 15 over 4. So we have two improper fractions. But again, take note that our denominators are different. So we need to have a common denominator. Quickly, we find the LCD. Multiples of 12 will give us 12. Multiples of 4 will give us 4, 8, and 12. 12 is the common multiple. So our LCD is 12. we find a number that if we multiply 12 with, will give us what we seek for an LCD, 12. That number is 1 for our 77 over 12, which is the fraction we seek to change. 1 over 1 times 7 over 12 will give us the same 7 over 12. We do the same thing for 15 over 4, and we have 45 over 12. These are fractions that now have the same common denominator, 12. Now we can easily carry out our subtraction. 77 minus 45 would give us 32, all over our common denominator, 12. 32 over 12 can be simplified to give us 8 over 3. 8 over 3 is our answer, but by convention in mathematics, we do not leave fractions as improper fractions for an answer. You can convert them into the mixed fraction form, where we may leave that as our answer. 8 over 3 is simply 3 goes into 8 2 times, that's 2 whole number. We have a remainder of 2 all over 3. And that's our mixed fraction. We leave our answer in that form. Now, fractions can also easily be multiplied by following 3 simple steps. All right? The steps are multiply the numerators together. Also, multiply the denominators together. Simplify the fraction if needed. They are very simple rules. But take note that if you have mixed fractions, again, convert them first to the improper fraction form before you carry out your multiplication. Also, if you are multiplying whole numbers by a fraction, make it a fraction by putting it over 1. Let's see what we mean. Let's take an example. If you were asked to simplify 3 over 5 of 4, take note of the word of. All right? In maths, when you come across situations like this, of refers to a multiplication. It's saying 3 over 5 times 4. 3 over 5 of 4 again means 3 over 5 times 4. The rule we just learned now said whenever you have a whole number and you are multiplying by a fraction, make it a fraction of itself by putting it over 1. 4 can be expressed as 4 over 1. So we have 3 over 5 times 4 over 1. Go ahead to multiply the numerators, 3 and 4. 3 times 4 will give us 12. Also multiply the denominators, 5 times 1, which will give us 5. 12 over 5 is our answer. But again, 12 over 5 is an improper fraction. And by convention, we don't leave our answers as improper fractions, okay? We may leave them as a mixed fraction. So find the mixed fraction form of 12 over 5. 12 divided by 5. 5 goes in 12 2 times. So we have 2 whole numbers. We have a remainder of 2 all over 5. And that's our mixed fraction. Let's take a look at another example. Simplify 1 whole number 1 over 2 times 1 whole number 2 over 3. Again, by convention, when we want to operate calculations in fractions, we make it improper fractions from the mixed fraction form. So convert our mixed fractions here to improper fractions first before we carry out our multiplication. 1 whole number 1 over 2 will give us what? 3 over 2. 1 whole number 2 over 3 will give us 5 over 3. So we are multiplying 3 over 2 times 5 over 3. Multiply the numerators 3 times 5 to give us 15. Multiply the denominators 2 times 3 to give us 6. 15 over 6 is our answer. But again, we do not leave our answers as improper fractions. So we convert 15 over 6 to a mixed fraction form, which would give us 2 whole number 3 over 6. And of course, 3 over 6 can be further simplified. And that would give us 3 in 3, 1, 3 in 6, 2. So that's 2 whole number 1 over 2. 2 and a half is our answer. Now, fractions can be easily divided by following 2 simple rules. All right? The first rule says multiply the number, that is, if it's a whole number or a fraction given to us, by the reciprocal of the fraction. Next, simplify the resulting fraction if possible. I'm sure we are wondering what a reciprocal is. It is simply, for instance, if we have 2 over 5, the reciprocal is simply turning the numbers upside down. 2 over 5 can be rewritten as 5 over 2. 5 over 2 is the reciprocal of 2 over 5. All right, so that's what we mean. Let's go on. Note, if you have mixed fractions, first change them to improper fractions before multiplying them together. Also, if you are dividing a whole number by a fraction, again, make that whole number to be a fraction by just putting it all over 1. Let's go ahead to try out some examples. If you were asked to simplify 2 whole number, 1 over 4, divided by 3 over 7. Let's quickly change our mixed fraction here to an improper fraction. 4 times 2, 8, plus 1, 9. 9 over 4 becomes our improper fraction form of a fraction 2 number 1 over 4. Next, we can rewrite our question as 9 over 4 divided by 3 over 7. The rule says that our division here turns to become a multiplication operation, while our 3 over 7 is rewritten as its reciprocal. That's what we mean. So we write 7 over 3 instead of 3 over 7. So 2 things has happened. Our division sign turns to become a multiplication sign, while the other number after our division sign is rewritten as its reciprocal. So 9 over 4 divided by 3 over 7 simply becomes 9 over 4 times 7 over 3. That's how you divide fractions. So let's go ahead to divide or to carry out our operation. 9 times 7 would give us what? 63. While 4 times 3 would give us what? 12. If we simplify this, 3 goes in 63 to give us 21, while 3 goes in 12 to give us 4. Hence, we have 21 over 4 as our answer. But of course, this is not the form in which we want it because it's an improper fraction form. Our answer should be in the form of a mixed fraction. 21 over 4 can be rewritten as 5 whole number 1 over 4. And that's our answer. Let's also see if we can simplify our question here. 3 over 10 times 35 over 36. All over 14 over 5. Let's try and rewrite this. If we rewrote it, we simply have 3 over 10 times 35 over 6 divided, this all over sign tells us there's a division, divided by 14 over 15. Let's carry out the 2 operations that we need to do. This division sign, like we said earlier, becomes a multiplication sign. There is a transformation. Also, the fraction after our division sign, which is 14 over 15, is rewritten in its reciprocal form, which becomes 15 over 14. So we have 3 times 35 times 15, all over 10 times 36 times 14. Let's see if we can simplify what we have on the board. 3 goes here, 1. 3 goes here, 12. 5 goes here 3 times. 5 goes here twice. Again, what else can we have? 3 goes here, 1. 3 goes here, 4. So we have 35. All over 2 times 4 is 8. 8 times 14 is 112. 35 all over 112 is our answer. But it can be further simplified. All right? 7 goes in 35 will give us 5. 7 goes in 112 will give us 16. 5 over 16 is the lowest term possible. And therefore, that's our answer. And so we've come to the end of our class for today. But first, let's take a recap to see if we remember all that we have learned today. We learned that fractions can exist in different other forms. One of those forms we learned about is the percentage form. We said it's a type of fraction whose denominator is always 100. And the symbol for percentage is this. 30 over 100 can be rewritten as 30%. This is pronounced as 30%. To convert percentages to fraction, we follow two simple steps. We write down the percent divided by 100. Then we simplify our fraction to its lowest term. To also convert fractions to percentages, we said we follow three simple steps. Find the number that can multiply the denominator to give it 100. When you have that number, multiply the numerator and denominator, that is the top and the bottom of your fraction, by that same number. Then you rewrite the fraction in the percentage form by adding whatever value that we have as our numerator. We add our percentage sign to it. We also learned about decimal. We said the decimal is another form in which fraction can exist. We said the decimal form of the fraction has its denominator as a power of 10, and it is expressed by figures placed to the right of a decimal point, that is a dot. We learned that 4 over 10 can be rewritten in decimal form to be 0.4. To convert fractions to decimals, we learned that we can follow three simple steps. Multiply the fraction by a denominator, which is a power of 10. Divide the top and the bottom of our fraction by the initial denominator. Write down the top number, then write the decimal point, one space from the right-hand side for every 0 in the denominator. To convert decimals to fraction, we said, write your decimal over the number 1 and simply multiply the top and bottom by 10 for every number after the decimal point. We would have our fraction of which we may simplify if the need arises. And so we've learned so much today. To test ourselves further, we're going to do 2 quick questions just to see how far we have learned. 1. If it takes one whole number, 3 over 4 meter of a cloth to make a shirt, how many shirts can a maker make from 10 whole number, 1 over 2 meter of cloth material? All right, from all that we have learned, we can think on these questions and simply solve them. Let's see if we can find out what they are asking. All right? It takes 1 whole number 3 over 4 meter to make a shirt. That is 1 whole number 3 over 4 meter is equal to 1 shirt. And we need to find out how many shirts we can make from this material. Okay? It simply means that to get the number of shirts, we'll divide 10 whole number 1 over 2 divided by 1 whole number 3 over 4. This is a shirt, and we need to find out how many shirts we can get from this material. Do we understand? So now that we know what to do, let's go ahead to solve it. What do we do first? We express our mixed fractions as what? Improper fractions. 10 whole number 1 over 2 would give us 10 times 2, 20, plus 1, 21, all over 2, divided by 1 whole number 3 over 4. In improper fraction form would be what? 4 times 1, 4, plus 3, 7, 7 over 4. So this is what we have to solve. 21 over 2 divided by 7 over 4. What are the 2 steps we learnt about? We simply say 21 over 2. Our division sign turns to a multiplication sign, while the fraction after our division sign is rewritten in its reciprocal form. So we have 4 over 7 instead of 7 over 4. 2 here, 1. 2 here goes 2 times. 7 here, 1. 7 goes in 21 3 times. So 3 times 2 will give us what? 6. It means that our material here can make 6 shirts. So let's see which of our options are correct. Is it A, B, C, or D? Option A has 6, and that is correct. Next, let's take a look at this question. During a week, Amina spends 1 over 3 of her time in bed, 5 over 24 of her time in lessons, okay? 1 over 8 of her time doing her homework. What fraction of her time, is left for doing other things? To handle questions like this, imagine her time, all right, to be like a whole pizza. that if you have one pizza, every fraction is broken off from the pizza. All right? 1 over 3 over time is broken up from her whole pizza. 5 over 24, whatever fraction that is also broken up from her whole pizza. 1 over 8 over time, all fractions are broken up from a whole. A whole is 1. So 1 is her whole time. The addition of all the time that she spent, we'll subtract it from the whole time to get whatever is left to do other things. So we have 1 over 3 plus 5 over 24 plus 1 over 8. All right? Remember our rules. 1 is a whole number. We express it as a fraction by saying 1 over 1. Okay? So let's simply say 1 over 1 minus all of this. How do we add this? When we have what? Different denominators. So what do we need to do? We need to quickly find the LCD and get them to have the same denominator. To get multiples of 3, we'd have 3, 6, 9, 12, okay, 15, and so on. 24, 15, we also have 18, we also have 21, we also have 24, we also have 27. That's multiples of 3. It goes on and on. We also have 30, we also have 33. While multiples of 8 would have 8. 8 times 2, 16, times 3, 24, times 4, 32. Okay, so what is a common denominator here? 24 is common, all right? Is that the least? And it is also the least. So 1 is our whole. We add up all the fractions of the time that she spent to be 1 over 3 plus 5 over 24 plus 1 over 8. We'll find the LCD to be 24. Let's convert 1 over 3 to be, okay, a fraction that has denominator 24. Find a number that will multiply 3 by, that will give us 24. That number is 8. Multiply top and bottom by 8. 1 over 3 times this would give us 8 over 24. Same for 5 over 24. That would be 1 times 1 over 1. That would give us same 5 over 24. While 1 over 8, the number that will multiply 8 by to give us 24 is 3. Multiply top and bottom by 3. That would be 3 over 24. Now that we have our equivalent fractions, let's add them up easily. So we have 8 over 24 plus 5 over 24 plus 3 over 24. We simply add up the numerators. 8 and 5 is 13. 13 and 3 is 16. 16 over 24 is our answer. 24 is the common denominator. This can be further simplified. 2 in 16 will give us 8. 24 will give us 12. 2 again in 8 will give us 4, while this would give us 6. 2 again in 4 will give us 2, while this will give us 3. So 2 over 3 is the addition of 1 over 3 plus 5 over 24 plus 1 over 8. We conclude our work by subtracting 2 over 3 from 1 over 1. Again, we need to find an LCD, which is 3 in this case. We simply multiply 1 times 3 to give us 3. Convert 1 over 1 to give us a fraction that has its denominator 3. Let's use 3. So we have 3 over 3. This would give us 3 all over 3. And of course, 2 over 3 is the same as 2 over 3. So we simply say 3 over 3 minus 2 over 3. This, of course, gives us 3 minus 2, which is 1. 3 is our common denominator. So 1 over 3 is our final fraction that is left for doing other things. Which of these options has our correct answer? C does. So C is our correct answer. And so we've come to the end of our class for today. I'm sure by now you know how to convert fractions to its other forms, such as percentages and decimals, and also know how to carry out operations such as addition, subtraction, division, and multiplication on fractions. It was a pleasure for me taking you in this class, and I look forward to seeing you in our next class. For me, it's bye for now. Thank you.